Wow. Welcome to our NS YouTube data channel. So in this video we'll continue looking at vectors. Specifically today we'll look at addition and the subtraction of vectors. So before we start, please, this is a continuous video of a previous video. So I am encouraging you to first go and watch the introduction on vectors, because if you just come direct here, you will not understand some things. Therefore, don't forget to hit the right button and subscribe to our channel. Otherwise, you are very welcome to this channel. So, let us continue and look at subtraction and the addition of vectors. In this video, let me give you an example. Let's say we have vector A, which is being added with the vector B. Now, when you are adding vector A and vector B, it is really important to remember that vector A has the x and y component, even vector B has got the x and the y component, in which A can be written as the ax component, comma, ay component, and vector B can be written as bx component and the by component. Now, in this case, if we want to add, as we are requested to do, it is very important that ax adds with bx and the ay adds with the by. Now, how do we find these components? Watch the previous video. You will know how we can find these components: x component, y component, and y component, so that we add. So, in this video, we will not waste much of time. Let's go and look at one of the examples that we can deal with. Now, they're saying the given vector components correspond to the vector r as schematically shown in the figure. Okay, so now we have got this diagram which shows y-axis and this one as x-axis. Then we also have the vector which is going this direction, which is called the vector r. Now here we have got a value which is already given here. This is negative 9.5 meters. Then here we have been given 14 meters. Then they are saying use the inverse tangent to find the angle. Okay, so they want us to use tangent to find the what? The angle. Tangent function. Now, we know that last time on the previous video, we said to find the theta is equal to, we need to use the inverse of tan, whereby we divide the y and the x components like that. In this case, let's come and identify y and the x component. Okay, now we already know to say this is the x component here. So on the x we have 14, then on the y component, this line is parallel to this y axis. So we consider this value which is reaching here to be this point, which means the same distance from here up to here. Therefore, we will consider this value as the y component. So we are going to say theta is equal to the tan inverse of y, which is negative 9.5, which is being divided by 14. Okay, so when we manipulate, what do we get? Let's do the calculations. Okay, so they are saying this is 34.195. It goes. Yeah, it goes. Now, we round this off to one significant figure, I mean two significant figures, then we're going to say this is just 34 degrees. So, it is a negative, don't leave out negative. Don't leave out negative. So, we are done with the first question, so we consider this as a. Now, another question, it is saying, question B. So, question B says, use the Pythagoras theorem to determine the magnitude of r. Use the Pythagoras theorem to determine the magnitude of r. Now, we are not going to waste much of time because we already talked about the equations. Therefore, we'll just go direct and talk about the magnitude or solve the magnitude of what? R. In this case, our x component is 14. So 14 squared plus the y component, which is negative 9.5. So we square this. What are we getting? What are we getting? That is 16.918. So 16.918. Then it continues. Now, our main interest is you round this off, so it will give us 17. So which means the magnitude of r is 17. Therefore, our answers are supposed to be r, which is negative 34 degrees, comma 17 meters. This is the first two questions. Now, the third question, it is saying, show that the direction will remain the same, but the magnitude will double if both Rx and Ry are doubled. So we want to show that the the direction, which is the theta, will remain the same even if we double the x component and the y component, which is the same as the magnitude. Therefore, we are going to say we double this, so we'll say theta is equal to the tan inverse of y, which is negative 9.5 multiplied by a 2 here, over the x, which is 14 times 2. Okay, now do the calculations. What are we getting? Okay, so we can see that the answer will remain as negative 34 degrees. So to find the magnitude, at first we found that it is 17, but remember we are doubling this. So our final answer will be 17 by 2, which is giving us 34. Therefore, the expression for doubled r will be r, open bracket, negative 34, comma 17. So this is in meters, this is in degrees. So these are the answers for the first question. Now, let us proceed to a second question. Question 2, which is talking about, it says, the vectors involved in this problem are shown below. Okay, so we can see the diagram there. Set the length of A plus B equal to 37 units, which means they're saying A plus B is equal to 37 units. So this is 37 units. Okay, now the question says solve for B. Solve for B. Now, this question was really simple. Why was it simple? Because if we check B here, we can see that B is here, which means the values of B are these. So now, just breaking down this B into components, we find that B will be equal to, open bracket, and the x-axis. So remember, this is our x-axis, this is our y-axis. So in the x-axis, we can see that B is along positive what? Positive y. Now, if B is along positive y, what does it mean? It means that the component of x is what? 0. The component of x is 0. Because in x-axis, y is equal to 0. Then in y-axis, x is equals to 0. So those are points that you have to understand. Now, apart from that, let's check on the y component of b. So the y component of b, we can see that this is the point here. This is the point. So this is the 30. Therefore, these are components of b. Now, what are we supposed to do? It is really simple. We want to calculate the units for b. Therefore, we will go direct and calculate the magnitude. But how do we calculate the magnitude? The formula is already known. So we will do this 0 squared plus 30 squared, in which b squared is equal to 0 squared is just nothing. So we get rid of this 0. We remain with the root of what? 30 squared. So this is square and this is square will go. So we remain with b as a 30 units. 30 units. Okay. In the next video, we will use another method to calculate the units of b. So please don't forget to follow so that you can be able to see with the other methods that you can use to solve the units for b. Now, let us proceed to question number 3. Now, question number 3 was really interesting. They are saying, okay, question number 3. Okay, a displacement d of 100 meters from the origin of an angle of 37 degrees above the x-axis. So they are saying d, which is 100 meters, this is the magnitude, comma, 37 degrees above x-axis. Now, when you identify these angles, remember we have got this one, the x or y plane. Here we have got x, then here we have got y. Now, what is the next thing? The next thing that you have to know is this is the positive x, so this is positive x, this is negative x, this is the positive y, this is the negative y. In this case, any value which is above x axis here, it is somewhere here between this and this one. So, according to the instructions that we have been given, they are saying this vector d was above x-axis. Then after being on x-axis, it was 37 degrees. So we can say this is our vector d, which is 37 degrees. Okay, 37 degrees. Now next, they are saying is the result of 3 successive displacements. Is the result of 3 successive displacements, which means they added 3 vectors for them to find this d. What are those vectors? Now they are saying there is d1 of 100 meters, d1 of 100 meters, comma, d1. Now, d1, which is 100 meters, along the negative x-axis, along, which means only the line or in the line of negative x-axis, which is here, within this line of negative axis. So therefore, we can say this is our 100 meters. This is our 100 meters, which is along negative x-axis. Now the question is, if they say so, what is the angle? Remember, we are getting angles starting from positive x-axis going in this direction, which is anti-clockwise. Therefore, from here up to here, we know that this is a straight line. So this is a straight line. Therefore, the angle is going to be 180 degrees. 180 degrees. Then from there, we have known the magnitude and the direction of vector d1. Then, vector d2. What are they saying about vector d2? They are saying vector d2 of 200 meters at an angle of 150 degrees. So 200 meters, 150 degrees direct above the x-axis, which means it is also above x-axis. We know that this is 0, 90, then here maybe this is somewhere 150. So this will be our 150, which is d what? 200, sorry, 200, which means this is our D2. Next, they are saying, and a displacement D3. Displacement D3. Now, what are the components of D3? We are not given. So if we are not given the components of D3, then we can say on the magnitude, we will put a question mark. On the direction, we'll put a question mark. We are not given anything. So the question is, find D3. Find D3. Now, this is the data that we have corrected, and we have written it here on a simplified form. Therefore, we will go ahead and solve this problem. Now, remember, in the previous video, we talked about how to form formulas. In this case, let us assume that we know the formulas already. Then, today, we'll use this method of a box, where we are forming a box. Now, in this box, the box must have about 3 columns. 3 columns. It must be sizable enough. So this is a vector. We'll be writing vectors here. Then this is x component. And the x component formula, it is saying magnitude cos theta. The magnitude cos theta. Then for y component, which is equal to the magnitude sin theta. Magnitude sin theta. So we are going to close here. Now, vector d1. I want this d to be last. So don't say why is it like this or what. We'll put this d at the end. So we'll start from d1 here. We'll start from here. Now, d1 is saying d1. It is saying the magnitude is what? 100, and the direction is 180. Therefore, in the x component, we'll just say this is 100 cos what is our angle? 180. So we'll find the answer here. Then on the y-axis, it will be 100 sin theta, which is 180. We'll find the answer here. Next, we will go and deal with the D2. Now, on D2, they are saying the magnitude is 200 and the direction is 150. Therefore, for x component, it is 200 cos 150. 200 cos 150. Then on the y-axis or y component, which is 200 sin 150. Then we will put our answers here. Yeah. Please don't forget to like and subscribe to our channel. It is just a reminder. Then we continue. D3. What is our D3? Our D3, we are not given anything here. So this is a question mark. This is question mark. We don't have anything. So we'll proceed to D in general. D in general. So D in general, which is capitalized like this, and they are saying it was 100. Remember, this is our magnitude and this is our direction. So 100 cos our theta, which is 37. We'll put the answer here. Then here it will be 100 sin 37. These are degrees. So we'll put in the answers there. So then we will close our table. So let's go and calculate those values. Okay. So we calculate those values. Let's calculate those values. Let's calculate. Yeah, feel free to pause the video. Feel free to pause the video and do the calculations. Okay. Now, according to my answers, here I got negative 100. I got negative 100. Then I got a 0 here. I got a 0 here. Next, D2. I got negative 173.2. 173.2. Then on the other one, I got 100. I got 100. This is according to my calculations. So try your method. You are free to try your method. Then D3 we are not given. Then D in general, I am getting 79.9, which is here, 79.9. Then the other one I'm getting 60.2. Okay, now since we have our components broken down there, what is our next stage? Our next stage is to go back to the question and try to understand what they are trying to tell us. Now, these people are telling us that a displacement D, which is this and this, was found due to the addition of 3 successive displacements, which means they were adding this D1 plus this D2 plus this D3. Now, remember, we said when you are doing those calculations, we need to add x, y, then from there we proceed, we find the magnitude, then we find the direction. In this case, we will proceed and add. Therefore, we're going to say D1x will add with D2x, which will add with D3x, which is going to give us dx in general. Then for y components, we are going to say d1y plus d2y plus d3y, which is going to give us dy in general. Okay, this is how it is going to be. Now, we will start getting the value since we already have those components. D1x, which is negative 100, D1x, which is negative 100, which is adding with D2x component, which is 173.2, then plus D3x, we don't know, we don't have anything here, so just write it the way it is, like there. Then dx, which is 79.9. Okay, now after doing that, where are we going? Simple. We add this. Now, what do we get when we add this? What are we getting? What are we getting? Okay, so here the value was negative. The value which was here was negative. Try with your calculator. So even here it was negative. So when you do the calculations, you are going to find that first you get a negative 273.2, which is plus D3x, which is equal to 79.9. Then from there, what are we going to do? We make this the subject of the formula. So D3x will be equal to 79.9. This one crosses the equal sign. What happens? It changes the sign. So it will be positive 273.2. Then, what are we getting when we add these? So D3x will be equal to 353.1. 353.1. This is the component of what? D3x, which is the component of x in D3. Then let's go to dy. Now, we get the values. The first value is 0, which is adding with 100, which is D2 here. Then in D3, we are not given anything. D3y, we don't have anything. Then in dy in general, which is 60.2. Then from there, what are we going to do? We make this the subject of the formula. 0 plus 100 is just 100. So we say D3y, which is equal to 60.2. This one crosses the equal sign. What will happen? It will change the sign. So we'll say this is minus 100. Then D3y is going to give us what? What are we getting when we do that calculation? Which is negative 39.6. Negative 39.6. Now the question is, are we done NS data? No, we are not yet done. We have just calculated the x and y component of D3, which means we need to find the magnitude and the direction of D3. The magnitude and the direction of D3. Since we have these components, then we can remove this table so that we find some space. Oh, let us just leave it there. We'll calculate from here. Now, we know that for us to find the magnitude, it is really important to know that magnitude, which is for D3. Therefore, we will say D3 will be equal to the square root of D3x squared plus D3y squared. What are those values? D3 will be equal to D3x squared. Where is D3? This is the one, which is 353.1. So 353.1 squared. This must be squared under the proper square root. Then D3y, which is equal to negative 39.6 squared. It is squared like that. Now, what are we getting when we do the calculations? Let us calculate. Feel free to pause the video and calculate. So now, according to the answer I am getting D3, which is equal to what are these values? This is 355.2.3359. Okay. 3.33 it goes. I'm not interested with other numbers. Okay. So that is my interest. Therefore, what will be our conclusion? So our conclusion is this is 355, not 33. Okay. So my conclusion will be D3 is equal to 355 as the magnitude. Then let's go to the direction. Now, direction will be found as theta is equal to the tan inverse of open bracket y component. The y component of this vector is negative 39.6, which is being divided by what is the value for the x component of D3, which is 353.1. 353.1. Then we close there. Next, theta will be equal to, what are we getting? Let's do the calculation. Let's do the calculations. it is giving me negative 6.4. Negative 6.4. Now, what are we supposed to do there? When you find such a situation, remember we have got what is called the Argandis diagram. Under the Argandis diagram, we know that we have got something like this, where we have got all of them which are positive. Here we only have sine, which is positive. Here we only have tan, which is positive. Then here we have cos, which is positive. The rest are negative. So cos is positive here, the rest are negative. Tan is positive here, the rest are positive. Sine is positive here, the rest are negative. Now, looking at our trig ratio that we have used here, we have used tan, but we are getting a negative here. Now, what should we do? It is really simple. It means that our answer might belong in. So, since we have found here a negative and we used a trig ratio which is tan, then we will come here. So, what does this mean? It means that our answer cannot belong in the third quadrant or here. Therefore, we suspect our answer to fall in this quadrant here where tan is negative, and this quadrant where tan is negative. Therefore, what are we supposed to do? Now, to find the value which is in here, what are we supposed to do? We know that the equation that we use here to find the angle, we say theta is equal to 180 minus that angle you have gotten. Then here we say it is that theta is equal to 360 minus that angle you are dealing with. Now, here it is theta which is equal to 180 plus. So here we add. Now, let us come here and see what can happen or what we can do. So now, since we have gotten this value, we are going to say theta will be equal to 360, which is minus 6.4 here. What are we getting? 360 minus 6.4. Feel free to pause the video and calculate. What are we getting? 353.6. Okay. Theta is equal to 353.6. Okay. So this one will be our final answer here. It will be our final value. Okay. So our final values, this is the magnitude, this is the direction. So the values will be 355, 353.6 degrees. So these are the magnitude and the direction of what? D3. Okay, now this is our final answer. Now, please welcome to NS YouTube channel. We'll be posting a number of videos. So under vectors, we still have other videos that will be posted very soon. Therefore, don't forget to hit the like button and subscribe to our channel. I love you all.